We have now covered solving system of equations graphically and algebraically using substitution. Now we're going to cover elimination. And elimination is where we're going to spend the majority of this lesson on. Simply because graphing isn't great. It's visual, but it's got to be precise and it only works for whole numbers. Substitution does not work for every system easily. It can work for everyone. Let me make that very clear. Substitution will work for every type of system, but sometimes it will not be easy to use that method. Elimination will work for every single one. So we're going to solve this one again a third time. We have now solved this one first by graphing, where we got -1/6. Then by using substitution, where we again got -1/6. We're going to solve this one a third time by our third method. Now, while we have solved this by graphing and by substitution, this one is perfect for elimination. When we solve by elimination, what you want is to have the variables be opposite but the same. So you've got -1 and +1. Those are going to cancel or eliminate. And now elimination is also called addition method. Now you're going to add what is left. So 2x plus 3x gives me 5x. -8 plus 3 gives me -5. And now I have one variable since I have eliminated my y's. So now we'll divide everything by 5 and we get x equals -1. Now we will substitute that back in to get our y because this is only half of our answer. So you can substitute this into the top one or into the bottom one. It does not matter. I'm going to go into the bottom one simply because it has all positive variables. So now that bottom one will be 3x, but my x is -1. So we've got 3 times -1, and then bring down the rest. Plus y equals 3. So this gives me -3 plus y equals 3. Add that 3 over, and we get y equals 6. Now again, my math lab will want x equals -1, y equals 6, but I like ordered pairs. So this is -1, 6. And so we have done it again. First by graphing to get -1/6, and second by substitution to get -1/6. Now by elimination. Okay, all three of these things get the same result. You're just going about it by different methods. So let's practice this again on part B. B isn't quite as easy for us because this one already had something eliminate, but this one has nothing that's going to eliminate. So we have to multiply one of our equations by something. So if I multiply this top one and I want to eliminate my x's, 2 times what will get me to 6, and that's 3. Okay, so now this equation here will be 6x, 3 times y is 3y. The most common mistake with elimination, specifically when you have to multiply one of the equations, is we forget to multiply what's on the other side of that equal sign. But notice I put parentheses around that entire equation. So you're not just distributing that to the x and to the y, but also to the other side of that equal sign. So 3 times 4 is 12. And I don't need to multiply this bottom one by anything, so I'm just going to rewrite it, but I do like these to stack. Okay, and now if you notice, we have a positive and a negative. 6x, it always has to be positive and negative. So that cancels out. But if you also notice, we have a positive and a negative 3y. So that also cancels. So on this left side here, I have nothing left. Everything canceled, so I have 0. Same thing actually happens here, right? We have 12 and a negative 12. Those are going to cancel out, and I have nothing left on the right side. This right here is a special case. When all of your variables cancel out, and what I am left with is a true statement. This means infinitely many solutions. This is one of our special cases. Go back to that first video to see what infinitely many solutions is. Let's try C. Now on C, if I again wanted to get my x's to cancel, what would we multiply this top equation by? Okay, if you said 2, you are close. 2 times 2 gets me 4x, but then I'm going to have 4x and 4x, and that's going to add up to an 8x. So this needs to be negative. We need to change that sign with that. So now negative 2 times y is a negative 2y. And don't forget the 5. Negative 2 times 5 makes this equal negative 10. And I'm not doing anything to this bottom one, so I'm just going to carry it over, but I do like these to stack. And now we add. Negative 4 and positive 4 cancel out. These also cancel my y's. Negative 2 and positive 2 cancel as well. So I am left with 0 on the left side. However, when I add, we get negative 10 plus 8, and that's going to give me a negative 2. Does this make sense? No, those are not equal. So what I am left with is a false statement. When what I am left with is a false statement, this one is my no solution. So those are your two special cases. Both of these, the x and the y, both canceled out. But when I'm left with a true statement, that's infinitely many. When I am left with a false statement, that's no solution. Now, last one on this page for part D, if I want to stick with my x's here, and actually I can't really cancel out my y's easily. Yeah, we still could. I'm still going to do x's simply because it's a negative and a positive, so I don't have to worry about signs for the x, but we could still eliminate the y's. But if I eliminate my x's here, I can't multiply 2 to become something to become a 5. That's a whole number. So I'm going to actually multiply both of these equations. The easiest thing to do is to multiply them by the other's coefficient. So 2 here, 2 down here, 5 down here, so 5 up here. So now this equation here would become negative 10x plus 15y equals 5. Hopefully you remember to do 5 times 1. And then this bottom one would now become 10x plus 20y equals 30. Okay, again, remember to do 2 times 15. So now we have positive and negative 10. So those are going to cancel. Nothing else cancels here. So let's add what we have left. 15 plus 20 is 35y. 5 plus 30 is 35. Divide that 35 over, and we get y is 1. So now substitute it back in. You can do it to the top equation or the bottom equation, or even technically this top or bottom one over here, but those are bigger numbers. Why do that? So I'm just going to go with this bottom equation and plug in. So we have 5x plus 10 times y, which is 1, equals 15. So we'll have 5x plus 10 equals 15. Subtract your 10 over to get 5x equals 5, and divide to get x is also 1. So write this as an ordered pair. This one doesn't really matter because they both equal 1, but just to make sure we understand, we always write this as x comma y. So if these were two different numbers, even though I solve for y first, I'm still going to come back to x and write that x number first, and then comma your y. So our solution here is 1, 1. Okay, let's just keep on going. And let's go over an application problem. A movie theater sells tickets for $10. Each, that should probably be a comma, each senior receiving a discount of $2. One evening, the theater sold 525 tickets and has revenue of $4,630. How many of each type of ticket were sold? Okay, the first one, well, so first, let's assign what everything is going to equal. You can either say that X equals the $10, and then your senior citizen discounted tickets equals your Y. So you'll want to come over here and say X equals your $10, or X equals regular price, Y equals your senior discounted tickets, or make these make sense to the problem. I am going to have my $10 tickets be T, and then I'll have my senior discounted tickets be my S. So the first thing that we need to talk about is that we sell 525 tickets. So my first equation here, let me use 5. My first equation is T plus S equals 525. No matter how many of these tickets I sell, when I add them up, it needs to be the total amount of the tickets I sold. So whether this is 525, whether it's 300 and 225, it doesn't matter what those numbers are, but when I add them up, they need to equal my total amount of 525. The second equation has to do about the money. How much do my regular price tickets cost? These are $10. So we have 10T. Plus, how much do my senior discounted tickets cost? And that is 8S. Why is it 8S? They receive a discount of $2. And the total revenue is $4,630. So one is about the amount of tickets we sell, or the amount of whatever. And the second one has to do with the money. You assign the money to each variable and how much money you have made, sold, lost, whatever in total. So now let's solve. This one's not bad to solve by substitution if you wanted to. You could solve for S by subtracting, or okay. You could solve for T by subtracting the S over, or you could solve for S by subtracting the T over, and that would be fine. I'm going to go ahead and solve this one by elimination, since it's in the elimination kind of category here. So to do that, we can eliminate S or T. It does not matter. If I wanted to eliminate my T's, what would we have to multiply this top one by? Hopefully you said -10. If I wanted to eliminate S, what would we multiply the top one by? hopefully said -8. Okay, it doesn't matter which one you want to eliminate first, you're going to get the same answer no matter what. But I'm going to go with my t's. So when I multiply this top one by -10, we get -10t minus 10s equals -5,250. And then I'm not going to do anything to this bottom one. So I'm just going to bring it over so that it stacks. Okay, so now we have positive and negative 10t. So those eliminate. And now elimination is also called addition. Add what is left. -10 plus 8 is -2s. -5250 plus 4630 is going to give me -620. And now divide by -2, and we get s equals 310. That is only half of my answer. We need to substitute that back in, or just kind of logically you can figure it out, but do it to this one right here, this top one, this t plus s equals 525. We have t plus my s we just found to be 310 equals 525. Subtract your 310 over, and t equals 250. Now this one doesn't make sense to write it as an ordered pair because it's a word problem, right? Answer the question. How many of each type of ticket were sold? The movie theater sold 215 regular priced tickets and 310 senior discounted tickets.